Assalamualaikum warahmatullahi wabarakatuh. We are back to our second topic, which is energy systems and exercise. There are three major energy systems that provide energy for exercise that you should know towards the end of this topic. There are three major energy systems. You have to know the characteristics of the energy systems. You have to know to compare and also to contrast the three energy systems. You can give examples of physical activities, exercise or sports in which exercise is the predominant energy systems. Okay. So before we go to the three energy systems that used during the exercise, we have to know the overview of energy systems. And we know that the chemical breakdown of ATP to ADP is actually an exogenous reaction. That is, it is released energy. So what is actually ATP? ATP is adenosine triphosphate, where this ATP is actually an immediate source of energy in the body for activity and exercise. It means that if we want to use the energy, ATP is the immediate source of energy. Where this ATP can found in all cells of body and it stores potential energy in phosphate bonds. So this ATP, it releases the energy when it's broken down to ADP, or what we call as adenosine diphosphate. And as our body, we must restore ATP from ADP after use through what we call as a rephosphorylation. So it means that in order to restore ATP from ADP, it must go the process of what we call as a rephosphorylation. Okay, so adenosine, the ATP, the hydrolysis of ATP, so the ATP is split chemically where it leaving the adenosine diphosphate and what we call as a inorganic phosphate, and it will release the energy in an exogenous reaction. In terms of rephosphorylation of ADP to form ATP, an inorganic phosphate is joined to adenosine diphosphate to reform ATP. This endogenic process requires the input of energy, which is then stored as potential energy in the phosphate bonds of ATP. Okay. The production of force by muscular fiber will require energy. The direct source of energy for muscle force production comes from ATP, which is stored in the muscle cells, and when ATP is broken down to ADP, energy is released and can be used for muscle contraction. So again, if an individual muscle fiber is stimulated to produce force, then energy is required. The direct source of energy for force production by muscle comes from splitting ATP molecules that are stored in the muscle cells. So this process can occur very rapidly, particularly during high intensity exercise when the amount of force produced by muscles is very high. Okay, you can watch this video. So this is how the ATP and the energy used by muscles. when there is a contraction of the muscles, okay, when you want to use muscles for the exercise, okay, so the ATP will be broken down to ADP, then energy will be released. And this is used for the muscle contraction. So there are three major energy systems that are used to replenish ATP. Number one is known as a creatine phosphate. Number two, anaerobic glycolysis. And number three is oxidative phosphorylation energy systems. Each of the three energy systems has its advantages. For example, speed of action, amount of energy released, and also disadvantages. For example, duration of action. Okay, that we will look at here. Okay, so these are all these major systems will give energy during the exercise. So when we look at this table, the characteristic of these three systems, okay, we can look at how in terms of what we call the advantages in terms of the speed of action, where creatine phosphate give a very fast energy compared to oxidative phosphorylation. In terms of duration of actions, however, we can see that the oxidative phosphorylation will give very long energy compared to the creatine phosphate, which is very short. A preliminary word must be said about the use and interaction of these three energy systems because of their characteristics. For example, the speed, the duration. Each energy system may be used by the body under different exercise or activity conditions. In other words, certain activities may require the use of creatine phosphate systems, whereas the energy demands of other activities may be met using the aerobic or oxidative phosphorylation energy systems. The tendency, therefore, is to think of each of these energy systems operating to the exclusion of other systems. It is tempting to think of these systems as light switches. For example, when during a certain activity, one of the energy system is switched on to support the activity. The others, must therefore be switched off. This image incorrectly depicts the interaction of the energy system. Another what we call a better analogy for the operation of these three energy systems might be a series of dimmer switches. All three are on all the time. But in certain situations, one of the systems may be turned up more than the other two. A certain exercise or sport activity may have an energy requirement that results in one of the energy systems being the predominant energy system used for that activity. The other energy systems are active but to a lesser degree. As each energy system is described, example of activities that predominantly use that source of energy will be given, but one must recognize that the other energy systems may be in use to some degree at the same time. Okay. So, we are going to look at the number one of energy systems, which is the creatine phosphate energy system.